Hi, everybody. Welcome to another video in section 2 of Unit 5. In this video, we're going to talk just about discrete random variables. All right, so let's go ahead and jump right into it here. Okay, so a discrete random variable, like I mentioned in the previous video, lists all possible outcomes for a variable, a random variable, and assigns probabilities to each one. Okay, so very much like, or exactly like the example that I did in the last video, where we have the random variable is the number of heads when you flip a coin 3 times, right? There are specific values that that can occur for that variable, right? So you use discrete random variables often when you are counting something, right? That's the best way to think about it. You can also think about it as, could you list every possible value of that variable x, whatever it is, okay? We analyze these variables using the same strategies that we used for quantitative data. So if you remember Cuss and BS, right, talking about center, the unusual, shape, and spread, okay? It's exactly the same. You're using a lot of the same techniques here. It's just this time we're talking about a distribution of a random variable and not necessarily a distribution of something a little bit more narrow, which is what we've been doing up to this point. Okay, so if we're talking about discrete random variables and we're wanting to describe them, right? There are a couple of things that you have to know about any discrete random variable. Okay, so when you have a discrete random variable, you'll list all possible values of that variable. Each one of those has a corresponding probability, okay? So every probability has to be a number between 0 and 1, right? Because probability can't be less than 0% or more than 100%, okay? And the sum of all of the probabilities together has to equal 1, right? Because the x values up here list every possible outcome, right? And so if I combine all of the possible outcomes, then that means my total probability would be 1 or 100%. Okay, so if I want to find the probability, say, in the example here, there's 3 x values listed. So say I wanted to find the probability of x2 or x3, right? I would just add their individual probabilities, right? Probability of x2 plus the probability of x3, which I'm hoping reminds you of something that we did in the previous section. That's just the addition rule, okay? So to find the probability of any event, right? Remember, what goes inside the parentheses here is the event. You would add the probabilities of those particular values of x that make up that event, okay? So when we're talking about discrete random variables, and I mentioned a couple minutes ago in this video that we describe discrete random variables in the same way that we would describe other sets of quantitative data, which means we need to be able to pick out the shape, which you usually can do visually. Okay, we also have to be able to pick out the unusual, meaning like gaps and outliers, which again you can do visually. But the other things, center and spread, are a little bit more difficult to figure out, and you have to calculate them usually. Okay, when we're talking about a random variable, we don't call the center the mean, we call it the expected value. Okay, so if you hear the term expected value, that means mean or average. Okay, the way that you calculate the expected value for any discrete variable is you multiply every value of x by its individual probability and then adding all of those together. Okay, so that's how you calculate it. Calculate by multiplying each value of x by its corresponding probability and adding those values together. Okay, we have a formula that we use, and I'm going to do an example for you here and kind of show you what that formula looks like and why it works the way it does. Okay. And then we also have a formula for variance. Okay. So we can calculate variance for a discrete random variable. We don't have a specific formula for standard deviation. So we calculate variance first, and then whatever you get for variance, you take the square root of it to find the standard deviation. So standard deviation is the square root of variance. Okay. On the screen, both on the left and on the right side of your screen, you can see the formulas for mean and standard deviation. Okay, or expected value and variance, right? But then you just take the square root for standard deviation. So really the one I want to focus on, because it's the less complicated one of the two, is the expected value. Okay, so remember, you multiply each value by its individual probability, okay, and then add all of those together. Okay, so I want to give you an example of a data set and kind of show you how this works. Okay, so let's say I have a data set where I have 3, 3, 4, 4, 4, and 5. Okay, that's my data set. So normally, if you were to find the average of this data set, this is what you would do. You would do 3 plus 3 plus 4 plus 4 plus 4 plus 5, and then you would divide by the total number of data entries that you have, which is 6, right? That's normally how you would calculate your average. Okay, what expected value does is it does this just on a larger scale, right? Because what if instead of giving you 6 numbers, I gave you 600 numbers, right? That would be a lot, and that would take a lot of time to calculate. Okay, so rather than doing it this way, we do it using the individual probabilities, right? And here's why this works. Remember that probability, the probability of anything, is just the number of successes, right? Or number of entries that fit in that category, or, like there's lots of ways to describe that, okay? Divided by the total number of entries that you have, which we describe with the variable n. Okay, so what that looks like, okay, here, right, we could rewrite this data set as 3, but 2 times, right? 3 times 2 plus 4 times 3 plus 5 times 1, right? The numbers that came first are all of our x values, right? So this 3 is like x1, 4 is like x2, and 5 is like x3. Those are all of the possible values that our variable takes on, okay? And remember that we're dividing by the total number of successes, n, which is 6 in this case, okay? If you isolate and kind of separate the x values from how many of them there are, right? So you would have the probability that you would select the number 3, right? The probability that you would select the number 3 out of this set is 2 out of 6. The probability that you would select the number 4 is 3 out of 6, right? Because there's 3 4s out of my group of 6 numbers, right? The probability that I would select 5 is 1 out of 6. Okay, so these numbers that you see in pink right here are these probabilities, right? It's the number of successes, 2, 3, and 1, divided by the total number of options that you have, okay? What expected value does is it's the sum of these x values, which are here in orange, times their individual probabilities, right? So I can rewrite this kind of complicated thing as 3 times 2/6, right, plus 4 times 3/6 plus 5 times 1/6, okay? So what I have here is I have the x values, so this is like x1 and their individual probabilities, p1, x2, P2, and X3, P3, and I'm adding all of them together, right? Which is exactly what this formula says right here, right? That capital weird looking E thing, that's a capital sigma, and it just means sum. So I'm multiplying the individual X values by their probabilities and then adding them all up. Okay. Now you may be thinking, well, if I do that, I'm probably going to get a number that's larger than 1. But you should, because an expected value is not a probability. Remember, it's the average value of your variable X, which likely will be larger than 1, okay, in most cases. Right? Now, to calculate standard deviation, we have this very long and fanciful formula, but it's really similar to that long standard deviation formula that we looked at in Unit 2. Notice that you're taking individual X values and subtracting the mean, right? So very much like this, X minus X bar, right, from Unit 2, squared. We also did that in Unit 2. And then what we did is you remember we did like divided by n minus 1, took the square root. It's that really long formula for standard deviation, right? But I'm just trying to show you here that you have a lot of, and you'd have to sum all of this up, right? So you have a lot of the same elements here to calculate variance. So you're taking each individual X value, subtracting the expected value that you found, the mean, squaring, multiplying it by its corresponding probability, and then taking the sum, okay? Now, this obviously makes a lot more sense if you can see it actually worked out and see an example worked out. So that's what you're seeing here on the screen right now. Okay, so I have a discrete probability distribution right here. This is the number of prior convictions for prisoners at a state prison. So those values range from 0 to 4, and then each have their individual probabilities. Okay, so the way that I calculate the expected value is I'm multiplying all of these X values by their respective probabilities. So 0 times 0.16, 1 times 0.53, 2 times 0.2, etc. Okay, and then you're just adding all of those up. So my expected value is 1.29 prior convictions. Okay, so that's the average number of prior convictions for the prisoners at this individual state prison. Okay, the variance is much more complicated to calculate, right? Very rarely will you be asked to calculate variance by hand. Most of the time, they will give that value to you, okay? But they will often ask you to calculate an expected value. That is a very, very common, especially, well, on multiple choice too, but free response question that shows up a lot. Okay, but for variance, the way you calculate it is you take the individual X values. So 0 is my first one, subtract the expected value, 1.29, square that number, multiply it by its probability. Do that for every X value, and then add all of them together. So that is the variance, and then to calculate standard deviation, you have to take the square root of that number, okay? So my standard deviation for this data set is 0.931, and I should have put prior convictions on there. Okay, that's my standard deviation. All right, so I want you to give this this probability distribution, this question right here, give this a try. So I gave you a probability distribution of the number of students absent after a sporting event, a weekday sporting event. There's a probability that's missing, but remember, keep in mind that all of the probabilities together have to add up to 1 or 100%. Okay, and then if you want to find the probability, say that greater than 3 students would be absent, you would add their respective probabilities for any X value that fits the bill for the event. Okay, so pause the video and try these 4 questions that you see on your note page. So see if you can find those individual probabilities, expected values, and standard deviation, and then come back and check with me to see if you got the answer correct. All right, folks, so go ahead and check your answers against mine. So the first part asked you to find the probability that 2 students will be absent. Okay, so remember that all of the values, the probability values in this distribution altogether have to add up to 1. So all I did is I added these individual probabilities and subtracted them from 1. Okay, now the one thing I haven't pointed out yet, but I really should, is the way that we write the probability notation for these types of variables. Okay, it looks like this. So here, this asks what's the probability that exactly 2 students will be absent. So we're finding the probability that your random variable x takes on this value 2. Okay, so it's very similar to when we would write things like this when we did normal distribution. Remember probably that z was less than 0.37, right? And you would figure out what that probability was. Same idea. So this is how you write your probability notation. Okay, so the correct answer here was 0.25. Okay, B said, what's the probability that less than 2 students will be absent? Well, there are a couple of values that are less than 2 here, namely 0 and 1. Okay, so the probability that x is less than 2 is the probability that x equals 0 plus the probability that x equals 1, which is what you see on the screen. So your final answer was 0.53 for this one. Okay. This next part asks you to calculate the expected value, so you can see it fully written out both on the left and right side of your screen. Okay, the one thing that I didn't point out again previously that I should have is there are a couple of ways that we notate expected value. Sometimes you'll see it notated with a capital E of x, so this is the expected value of this variable x. You will also see it with your, remember your weird looking u, or this kind of curve, really weird looking m, okay, which means mean, but then you have to put a little subscript with the variable, right? So that we know this is the expected value or the mean of this specific variable x, okay? So remember, the way you calculate expected value, multiply the top row times the bottom row in each column, right? Multiply, which is what all of these are, and then add them all together to get the expected value, okay? Right? And then the last part of this question was to find the standard deviation, okay? So the whole thing is written out here on the left side of your screen. I did not write the whole thing out, okay? But basically what we did is took each individual x value, subtracted the mean or the expected value that we found in the last step, squared it, and then multiplied it by its probability. Did that for every value of x, added them all together, that gives you the variance. And then you take the square root of that number, whatever it is, in order to get the standard deviation. So when I did that, I got that the standard deviation, which again is represented by this little Greek symbol here, sometimes you'll see it written like this, so that we know this is the standard deviation of variable x, right? But the number that I got was 1.431 absences, right? So very last part of this video is mostly review, okay? Whoops. So the last part of this video, which I need to click through here, I didn't realize that I didn't have this clicked through already, is about transforming and combining random variables, which we've already done in Unit 3, right? So remember when we would take normal distributions and multiply them by a certain number, or add a certain number, and that would change the mean and the standard deviation, right? We would also add distributions together or subtract distributions, okay? It's the exact same thing that we did in Unit 3. So just as a reminder for you, when you are multiplying or dividing by a constant, the only thing that changes, right, is it changes the center and location. So like mean, median, quartiles, percentiles. It also changes spread, okay? But if you add or subtract a number, that's only going to change the locate, like centers and individual locations. It's not going to change spread. Because remember, when you're adding or subtracting a constant, all you're doing is moving or shifting your distribution up or down on the number line, okay? So that's what this kind of summary table is down here at the bottom of the slide, okay? The other thing that we talked about is the idea of combining random variables, right? So let's say you had one random variable that was, I don't know, number of children in a household, and then say you had another random variable y, which was the number of pets in a household, right? So you can find the combined distribution and you can find individual probabilities with the combined distribution. So let's say I wanted to know the expected value or the average number of children and pets together, right? So if you are adding random variables, the way that you find the mean and the standard deviation, right, or the mean and the variance rather, is you would add the individual means, right? So add the expected value of x and the expected value of y. Just add them together, right? If you want to find the standard deviation, remember you always add variances. You never add standard deviations because it won't work, okay? And then you have a similar idea for the difference of random variables. So if I wanted to find the expected value of x minus y, which doesn't really work with our context here, but we're just going to roll with it, right? You would subtract the individual means of each of those variables, but for variances, you're still going to add, right? Because no matter how you combine two distributions, you're compounding the randomness and the variance and the spread every time you do that, whether you're adding them or subtracting them. So you always add variances. But remember, never add standard deviations. So if you're given a standard deviation, right? So let's say I was told that the standard deviation of x was 2 and the standard deviation of y was, I don't know, 1.5. Sure. If I wanted to find the standard deviation of x plus y, I would have to first square the standard deviations to get the variances, right? So variances here would be 2 squared plus 1.5 squared, which is 4 plus 2.25. So my variance would be 6.25, meaning my standard deviation of x plus y is the square root of variance, or the square root of 625, which ends up being, or 6.25, which I'm pretty sure ends up being 2.5, but my math may be wrong on that. You'll have to check me on that one. Okay, so this part here was a little bit of a review, but it works for any random variable, right? So that's kind of why I introduced it to you in Unit 3, because when we were in Unit 3, we were talking about random variables. They were all normal random variables, but they were still random variables. So here I'm just letting you know that those rules that you learned apply no matter what the shape or type of random variable you are dealing with. Right? So that is it for this video. So discrete random variables are one of the main types that they like to use on the AP Stats test. The other two are binomial and geometric. So in the next two videos, I'm going to talk to you and explain a little bit about each of those types of random variables. So I will see you in the next video. Bye, everybody.